Hello everyone, welcome back to my channel. So in this video we are going to learn about bisection method. Okay, so we are going to learn about bisection method. If you are first time to my channel, please consider subscribing and encourage me to do more videos like this. So we are going to learn some of the important points regarding bisection method first. So it is also called, it means here bisection method. It is also called Bolzano method of successive bisection. Okay, so it is also called Bolzano method of successive bisection. So this bisection method is an example of interpolation method. Interpolation method. And what is the other name for interpolation method? Bracketing method. Okay, so I have discussed this interpolation method or bracketing method in my previous video. If you have not watched that video, I am giving the link, playlist link in the description. So go there, see that video and understand the difference between interpolation and extrapolation methods. Okay, so in this interpolation method, as I have told you already, we are taking two initial estimates. Okay, so two initial estimates are considered in the case of interpolation methods. I am assuming those two initial estimates as x0 and x1. Okay, so if x0 and x1 are the initial estimates which are assumed by using bisection method, the condition here to be followed is f of x0 and f of x1 should have opposite signs. Okay, so f of x0 and f of x1 should have opposite signs. That is, if suppose f of x0, this is just an assumption. So if f of x0 is negative, then f of x1 should be positive. Okay, so then only we can bracket the roots. Bracketing method. Why it is called bracketing method? We are bracketing the roots between those two initial estimates. So we can bracket the root between x0 and x1. Okay, so the condition is this one: f of x0 and f of x1 should have opposite signs. Okay, so now we have considered initial estimates, and then the successive approximation formula using bisection method is given by the next approximation. So next approximation is given by x0 plus x1 by 2. Okay, that means we are taking the bisecting value of the two initial estimates. That is why this method is called as bisection method. Okay, so x2 is equal to x0 plus x1 by 2. This is your first approximation. Okay, so this is your first approximation. So in this, after finding the first approximation, if f of x2 we are going to find, so we have to find, after finding x2 we have to find f of x2 value. So if f of x2 is equal to 0, then directly we can say that x2 is the root of given function f of x. Okay, so you are given with the function f of x, and x2 will be the root if f of x2 is equal to 0. Suppose if f of x2 is not equal to 0, if of x2 is not equal to 0, that means there are two cases again. So f of x2 may be either positive or it may be negative. Okay, so it may be either positive or negative. So if f of x2 is positive, then here f of x1 is positive and f of x0 is negative. So the now root lies between x0 and the new positive value, which is equal to, or new root which is equal to x2. Sorry, so it lies between, if f of x2 is not equal to 0, then it may be either positive or negative. So it is maybe either positive or negative. So if it is positive, then what can we write? So that now root lies between x0 and x2. Okay, so root lies between x0 and x2. Okay, so I'm cancelling this. So root lies between x0 and x2 only. Why? Because x1 is also positive and x2 is also f of x2 is also positive. In this case, the root lies between x0 and x2. If f of x2 is negative, it replaces the negative root. For the next interval of root, it replaces the negative root. That means x0 is going to be replaced, because f of x0 is negative and now f of x2 is also negative. So the root lies between x2 and x1. Okay, so this is how we can find the root. That means what we are doing here is we are decreasing the gap. We are decreasing the gap between initial estimates. Initial estimates by each approximation. By each approximation, we are going to decrease the gap between each initial estimates. Okay, so that is what we are going to do. So you'll understand this clearly when we solve a problem. Okay, so don't worry about that. I'll explain you clearly when I solve a problem. Okay, so we are decreasing the gap between the initial estimates with each approximation, because x2 is x0 plus x1 by 2. So it is the average value of x0 and x1. So x2 is always less than x0 and x1. Okay, so if the root is if we take x2 as a root, then it will be there will be a decrease in the gap between the initial estimates. So initial estimates are x0 and x1. So the new estimates will be either x0 x2 or x2 x1, depending on whether f of x2 is either positive or negative respectively. Okay, so this is how successive approximations can be found by using bisection method. So in bisection method, the other important point is the fastness of convergence. Fastness of convergence is very slow. Okay, because we are reaching on two sides of the polynomial. One is on negative side and other is positive side. Since we are reaching the true value on two sides of the polynomial. Okay, since we are reaching the true value on two sides of the polynomial, so fastness of convergence is very slow, and order of convergence is first order, or it is linear. Okay, so order of convergence is first order and the fastness of convergence is very slow, because we are reaching the true value on the two sides of polynomial. Okay, so these are the very important points regarding bisection method, and this is how we are going to find the successive approximations by taking the bisecting value of the two estimates. Okay, so if you consider these two as the estimates now, so what will be the next approximation? x3 will be x1 plus x2 divided by 2. In this case, x3 will be x0 plus x2 divided by 2. Okay, and again we are finding the value of f of x3 here, and the method goes on. Okay, so approximations goes on by using this formula. Okay.